let's talk about transformations of linear functions. Now, this applies towards all functions, but it just looks a little bit different when we're looking at the equations. But you're going to be amazed once you see the similarities and how it applies through all functions. But this gives us an opportunity to review a linear function, graphing a line and the different ways that we can write that equation. So let's look at number 1. It says graph y equal 2x and plot at least 5 points on the line, okay? So if you remember, the easiest way to probably do that is if we use what remember is slope-intercept form, just because of the way it's written. If it were written a different way, we would look at it a little bit differently. Or you could do a table of values, right? We could enter for x. So if we let x be equal 0, 2 times 0 is 0. So that would be a point on the graph. But for me, the easiest way is just to look at the equation in the form it's in now. So if we look at y equal 2x, y equal to x. Really, there's nothing here, so it's like saying 0. Remember, m represents your slope, and b is your y-intercept, which is where it crosses the y-axis. So I can see we cross the y-axis at 0, and then at y equals 0, and the slope is 2. Now, so another thing about slope, about slope is you'll remember it's rise over run. That means I always rise up and then run left or right depending on the sign. So, and we'll explore that. Our slope is positive 2. So if I'm going to write that, remember we kind of need that little fraction to help us. So a whole number, we can write it over 2. So that means I'm going to rise 2 and run 1. It's positive, so we want to be going up 2, and we want to run right 1. Up 2, run right 1. Oops, from the previous point. Rise 1, 2, run 1. So I can do several points. We can go on and on forever, rise 2, run 1. Or you can go in the opposite direction. You can fall 2 and run left 1. The main thing, and you can do it for as many or as few points as you want, they're requesting for at least 5. The main thing is that you want your line, because your slope is positive 2, you want your line to go, you want to be increasing. And just like we talked about in the last lesson, increasing and decreasing functions, positive slopes are increasing functions. So let's draw our line. Okay. So we always put arrows to indicate that it is a line and not a segment. It goes on forever in both directions. All right, so now that we've got a graph, it says translate the graph 4 units to the right by moving each point to the right. So that's what we're going to do. So that's why they're asking for 5 points. So you're going to take to the right 4 units. So I'm going to start with the 0, 1, 2, 3, 4. So from 0 to 4. Then here, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And you're just counting to the right 4 units for each of your points on the line. 1, 2, 3, 4. So, and you can do them all. Or you can see the trends. Like once we get our first one, I can still rise 1, run 2, rise 1, run 2, rise 1, run 2 to get those next points. But what we've done, so a translation, translate, to translate means to slide. Really to slide. So you can translate left, right, up, down. Okay. So write the equation of the translated line in slope-intercept form. So again, we're going back to the easiest method. Looking. So here's our point. So slope-intercept, you need 2 things, right? So slope-intercept form is y equals mx plus b. So here where M is your slope and B is your y-intercept. So those are the two things that I need. My slope, or excuse me, my y-intercept is -8 of my blue line, right? -8. And then your slope, it didn't really change. We're still going to rise 2, run 1, rise 2, run 1. And you're going right, you're ascending, going up the stairs. So again, you're positive. So your slope didn't really change. And if you remember from Algebra 1 or geometry, that's because they're parallel, right? All we did was slide it to the right. So my new equation, slope of 2, bring down the x, and then it's -8, so it'll be -8. So now, if you notice, we have a little bit in common. 2 and 8, it says factor the common factor in the translated equation. So here's our blue line, right? This is our blue line, our translated equation that it's referring to. And you'll see that each has a 2 and 8. Both have a factor of 2 in common, so we can factor that out. So if I factor out a 2, really factoring means to divide, right? So to factor out a 2, I'm dividing this by 2 and dividing 8 by 2. So we're writing it in such a way, so 2 divided by 2 is just 1, so that just leaves me an x. And you're doing it in such a way where if you were to multiply it, 2 times x is 2x. And then we would do the same thing, 8 divided by 2, that's -4. And if we were, 2 times -4 would give you -8. And so that is where that's coming from. That's what it means to factor. So you're really division, but you're writing it in multiplicative form. Okay, so there's our factored form. They both have a 2 in common, and so we just factored out a 2. What are the coordinates of the point to which the point 0, 0 is translated? So it's asking us to look at our graph on letter E. So here was our original 0, 0. We moved it 4 units to the right, and now here is the new location of that translated point. So here that coordinate is now 4, 0. Okay. Here, let's write it in here, 4, 0. Where does the amount of translation appear in the factored form of the equation in part D? Well, if you notice, what we have in common here is here's a 4, and here's our 4. So we might be able to see what is happening when it's written in this manner, okay? So it appears in the parentheses with the x. And it's also x minus 4. So notice that it's not actually +4, but it is -4. Okay, so let's do the same thing on number 2. They're asking us, we're using the same original line that we started with in the beginning. So scrolling up. To graph our y equal 2x, so we saw we started at 0, y-intercept is 0, and a slope of 2. We're going the opposite direction, just graphing the same line, rise and run, in the positive direction. Okay. All right, so that's we're going to call it our parent line here. So plot at least 5 points on the line. We did that. So now it says translate the graph 4 units to the left by moving each point 4 units to the left. So let's try that. So I'm always starting at 0, 0, moving that point first. 1, 2, 3, 4, even though it does not matter. So, and you're just taking each one of those points and moving it 4 units to the left. Okay, I know my line's not perfect, but So it says write the equation for the translated graph in slope-intercept form. So again, for slope-intercept form, that's that y equals mx plus b. We need our slope and we need our y-intercept. Where our y-intercept is easy to see here at positive 8. And if you'll notice, your slope here also didn't change. From point to point, you rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1, right? So you're ascending, it is positive. So your slope is 2. So writing this equation here, we are y equals 2x. And then your 8 is positive, so plus 8. So you'll notice this is very similar to the equation that we just wrote. D part says factor out the common factor in the translated equation. So again, they both have a common factor of 2. So we're going to factor that 2 out. 2 times x is 2x, and 2 times positive 4 is positive 8. So it says what coordinates of the point to which the point 0, 0 is translated. So we're doing the same thing, taking 0, 0. We went left. So now that coordinate point is at -4, 0. So what does that mean? Where does the amount of translation appear in the factored form of the equation in part D? Well, you can probably see now what is happening. So it is in parentheses again. With the x. Right? Whereas x plus 4. So a couple of things to notice, similarities and differences. Up here we went right 4 units. And here we went left 4 units. And I want you to just take a moment and look at those equations. We went right 4 units and left 4 units. Okay? That horizontal translation. All right, so now examine the equations in part D of questions 1 and 2, right? So that's what we were just looking at. So for 1D was y equals 2 times x minus 8, and 2D was y equals 2x, not 8, 4, minus 4, and y equal 2x plus 4. All right, so remember, how does the difference indicate the direction of the horizontal translation? So remember, in the first one, we went right 4 units. In the second one, we went left 4 units. So how do you think you can tell by looking at the equation? In the equation, see, notice that inside the parentheses here, it's really moving the opposite direction. And it's a horizontal translation, right? So you move in the opposite direction indicated by the sign. Okay? So whereas inside the parentheses, we've got minus 4, and here we went right 4, which we would think that would be the positive direction, right? Okay, so let's see why that is. So here I've got x plus 4 and then x minus -4. So really they're the same line, right? Because what does it mean to subtract a negative? So this is what I want you to do. You're going to say it means to do the opposite. Anytime you're subtracting, you're multiplying by a negative, you're doing the opposite. So for a horizontal translation, So for a horizontal translation, you're going to do the opposite. So if where it said up here, right here, x minus 4, that means we're going right 4 units. X plus 4, that means you're going left 4 units. That horizontal translation along the x-axis is what's moving in the opposite direction. So you're doing the opposite. So now, and that's what happens in the x here. So what's the significance of the common factor? So if you'll notice our common factor, let me get a different color here. So our common factor, 2, up here at the top, what did that represent in our equation before? That's our slope, okay? Did it change? It did not change. When we moved from left to right, it did not change. So that is your slope. All right, so let's look at the next one. Look at number 4 and see what happens. So by how much does y equal 3 times x minus 2 translate the line 3x horizontally? So you can probably guess, but let's graph it. Let's look at y equal 3x. So y equal 3x, here, y equal 3x. So that's a slope of 3 and a y-intercept of 0. So here's my y-intercept of 0, and my slope is 3. It's positive, so you're going up 3 and over 1, right? Slope is 3. Make it a fraction so you can get that rise over run. Just a reminder. So your rise 3, run 1, rise 3, run 1, and then do the opposite direction. And you'll notice if you run in the wrong direction, this is not a line. So you should quickly be able to tell, something is wrong. Let's back up and try again. Okay, so let's graph our line. There we go. All right, and then now, so the question says, by how much does y equal 3x minus 2 translate horizontally? So we know we're moving horizontally from previous experience, number 1, and number 2, it just told us. So what do you think this is going to tell us? If we think about where we went before, we're going to go right 2 units. We're doing the opposite, moving in the opposite direction. So, I answered both questions. We're moving right. We went 2 units and to the right. So let's do that. C part says to graph it. So we're just moving 1, 2, 1, 2, 1, 2, 1, 2. Okay, so here's our new line. Okay, so what is the x-coordinate of the point on the line y equals 3 times x minus 2 when the coordinate is 0? So here again, so here's 0. We moved it 2 units. So the x-coordinate is 2, right? So that ordered pair was 2, 0 because we went right 2 units. All right? So I want you to take a moment and try number 4. When you try number 4, you can check it here. Remember to pause the video if you want to try it on your own. Okay, hopefully you have attempted it on your own, and let's see how we did. All right, so by how much does it translate the 4 times x plus 2, translate the line y equal 4x horizontally? So we can see that's 2 units. And which horizontal direction is y equal? 4x translated. Remember, we're doing the opposite, so we went left. So let's graph using a horizontal translation. So here, I'm not going to graph the line. I know that this, because it's the 4x here, that we're passing through the origin. We found out we're just going to take that 0, 0 point and we're moving left 2 units. 1, 2. So, and then I have a slope of 4. So we know we're going left 2 with a slope of 4. So we're going to rise 4, run 1, rise 4, run 1, and do the same thing. So if we can just find that initial point, that 0, 0, use your slope to do that. It will pass through 0, 0 no matter what. And then, oops, that last point is off. Oops. Should have known that when we went through it the first time. Okay. So here's your line. That's how graphing using a translation, what you know about the equation, can do. So what's the x-coordinate of the point on the line with the y-coordinate of 0? So here's our y-coordinate, or excuse me, our 0, 0. We went left. So that would be at -2, 0. So that x-coordinate is -2. So we just use a translation to graph that linear equation. All right, so let's look at number 6. Use your graph to complete those missing values. All right, so graph y equal 10, x minus 3, using a horizontal translation. So again, I'm not going to graph the parent, the 10x, but we are going to use that. We know that this is the slope, right? And this is your horizontal translation. Okay? So you got to think about what's happening here. So we know we're at 0, 0. What direction are you going? If it's -3, we're going right 3 units because you do the opposite. So from 0, 0, you go right 3 units. And then what does the 10 tell you? What does that tell you? It's positive. So if I rise 10, I'm going to run 1. So we go all the way up 10 and run 1 unit for those points. And then I'm going to do the opposite. So it really does not matter what the slope is if it is written in this form, in factored form. We can graph any line. And that's what we used to always love about, it's not recognizing it because the slope's so steep. But that's what we used to always love about slope-intercept form, right? How it was so much easier to graph. But this graphing translations, I'm going to make my points a little more evident. Graphing using transformations applies to all types of functions. So if we can understand it with a linear function, we can apply that to any type of function. And that's what we're going to get into. All right, so now let's find the missing value. So what is x when y is 0? So that's right here. Y is 0 on the x-axis, so that is 3. And we should have known that here, right? When x is 4, y is 10. And when y is -10, here's -10, x is 2. So we can find any points. We can graph our function. Okay, so let's see what happens when we have a slope change. All right, it says graph y equals 1/2 x plus 3 using a horizontal translation. What is the x coordinate of the point on this line with the y coordinate of 0? So again, we're going to use the translation. So I'm starting where? Where do we start if we're just looking at this guy right here? Remember, y equal mx plus b. So if I'm looking at y equal 1/2 x plus 0, right? Because there's nothing there, so it's like saying plus 0. So now my slope is 1/2. So I'm going to rise 1 and run 2. It's positive, so we're still going to the right. We want our line to go up. So I rise 1, run 2, there's my next point. Rise 1, run 2, there's my next point. Okay? So starting at 0, 0, rise 1, run 2, rise 1, run 2, and go in the opposite direction. Okay? So now we have our line. And we're doing y equals 1/2 x plus 3. So what does that mean? We're moving to the left, correct? Remember, we're going to do the opposite. So if it's positive 3, you're actually going to the left 3 units. So I always start with 0, 0. And when you're graphing transformations, the origin is the easiest point to translate first, and then you can do the other points and work your way around from there, in my opinion. So see, because now I don't have to move every point to the left, which you easily could. But now, since we have our first point, we can use the slope to do that. Graph our first point, right? Move it here. And then rise and run to find your other points. Okay. All right, so the x coordinate of the point that is lined with y is 0. So we went left 3, so that's negative 3. So x is negative 3. Graph y equal 1/2 x minus 2. So what's that coordinate? So if I just went left 3, and I got negative 3 as an x, very similarly, if we're doing the opposite, if that says minus 2, we're going right. So I'm going right 2, and then I'm just going to use my slope from there. Rise 1, run 2. Okay, so again, our x coordinate is positive 2 because that's where we went. We went to the right 2 from 0. So that ordered pair would be 2, 0. Now it says plot the point 5, 0 and draw a line with a slope of 1/2 through the point. So 5, 0 is here, right 5, up 0. And a slope of 1/2, so we're going to rise 2, run 1, or excuse me, rise 1, run 2, rise 1, run 2. Okay, so here's our line. We've got all kinds of stuff going on this one. Okay, so this is our red line. So it says the equation of this line will be y equal 1/2 x minus 5. Explain how this is a horizontal translation of y equal 1/2. What happened to that from that blue line to get to the red one? what did we do? What changed? Well, we really only moved it right, what, 5 units? So that's translated, or moved right, right? Right, 5 units. Okay, that line, y equal 1/2 x, translated right 5 units. All right, so now let's look at number 8. And you'll notice these are progressing, just a little bit changes as we go. So this one says graph y equals -3 times x minus 4 using a horizontal translation and plot at least 5 points. So here, what's our parent function? I want you to think about it for just a second. What's the parent function? The original function that we're actually translating. It's everything except for what's with the x, right? So really it's this. So if that's my parent function, y equal -3x, you know you're going through 0, 0 with a slope of -3. Well, I'm taking that 0, 0 point, and what am I doing with it? What are we doing? What does that -4 tell us? That tells us we're going the opposite, right? So we're moving right instead of left for the negative, moving right 4 units. So that's what we're going to do. I'm going to take that 0, 0 point, and this is what I'm doing. So here's my point. I'm taking it, and I'm going to go right 4 units. 1, 2, 3, 4. So there is my actual first point. Okay? And then from there, I'm going to rise 3, run 1, right? Correct? Because if my slope, look in here, here's my slope. So my slope is -3, or even if you think about the parent function. Now it's negative, so I'm going to rise 3, but I'm actually going to run left because I want my line to be decreasing, right? Think about our intervals on the last lesson that we had. That is decreasing. Okay? Slope is positive, you want it to be increasing. Slope is negative, you want it to be decreasing. So I'm going to rise 3 and run 1 again, and on the other side. Okay, and you want to be sure that you're in a line. That's just a way to double check yourself. Draw your line. So using the translation without having to graph the parent function, we were able to graph the line that they were asking for. Okay, so let's look at B part. All right, so on B part, it says translate the graph in part A up 5 units. So I'm going to take any one of these points, and we're just going to go up 5 units. 1, 2, 3, 4. Well, that one doesn't have enough, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now remember, you can still just do the slope on those points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, so here's our line. What is the y coordinate of the point on the translated line when the x coordinate is 4? So here is my 4. So when I go up, I'm looking at that point right there. So my ordered pair, the coordinates, directions to get there is 4, 5. Here, let's do this. 4, 5. See it a little bit better. Okay, so that means the y coordinate is 5 when x is 4. That was from the point 4, 5. So the equation of the line, D part, can be written as y equal -3 times x minus 4 plus 5. Show that if x equal 4, then y equal 5. So, first of all, before we show that when x is 4, y is 5, I want you to look at this right here. Think about the translation from y equal -3x. we started, what was the first thing that we did? The first thing we did was we went right 4. Then we took it and went up 5. So looking at this equation, we can see we can go from 0, 0, go right 4, up 5, and then use your -3 to find your slope. It is so beautiful how easily this can be worked. And so it's not necessary to have slope-intercept form every single time. So here, on this equation, this is the equation of the line can be written. So when it says show that for x is 4, y is 5, it's asking you to plug it in, to prove it. So that means we're going to let x be 4 for our equation. So that means we're going to have 3, y equals -3 times, and we're plugging in 4, minus 4 plus 5. So all I've done is taken the equation, and this will come back to you, and I've plugged in 4 where x is. Anytime it's asking you to show that something is true, it just means to prove it. Show me. So now order of operations, right? -3. 4 minus 4 is 0. -3 times 0 is 0 plus 5. So y is 5. So that's how we get the ordered pair of 4, 5 algebraically. When I let x be 4, y ends up being 5. Remember, y depends on what the value of x is anyway. Okay? All right. Now let's see. We're looking at a little bit more of a translation. So hopefully you're starting to see a pattern in what is happening here. Okay, so let's look at number 9. So here we're graphing y equal 1/4 x, so that's your slope of 1/4. So that's a y-intercept of 0, 0, right? Because we're like plus 0, so it's like y-intercept of 0, rise 1, run 4. Rise 1, run 4. Do in the opposite direction to graph your line. All right, so now it says translate the line in part A to the right 2 units and up 3 units. Okay, so that means right 2. So I'm starting here at 0, 0, and I'm gonna go right 2 and up 3. So there's my first point. We've gone right 2 and up 3. Okay. So then from this first point, I'm going to use the slope of 1/4, just like, because we're doing the same line. So I'm going to go up 1 over 4. 1, 2, 3, 4. Up 1 over 4, and then go backwards up. Down 1, back 4, down 1, back 4. Okay, so here's our line. I only went back 3, didn't I? One, 2, 3, 4. Okay. All right, so then it says write the equation. So right here it says y equal m times x minus h plus k, where h is the amount of the graph that is translated to the right and k is translated up. So k is translated up and h is translated right. So let's look. So I'm going to write y equals m times x minus h plus k. And you can think of h for horizontal. And you're always going to do the opposite, right? So we could, instead of, we went right 2, so that's plus 2, right? So instead of minus 2, we're going to write plus or minus negative 2. Okay, so we're writing our equation, and this is what we're going to do. So that's y equals m, which is 1/4. Oops. And then we have times x. And then, so minus positive 2. So we moved right 2, which is like plus 2, right? So we're just going to do the opposite. So the opposite of positive is negative 2. Positive 2, right? Or if you think about it, you're saying minus because that's in the formula. And if you'll notice, we did the opposite of every other direction. You're doing minus positive 2, and then you're going up 3, right? So when you're moving the horizontal translation, you're going in the opposite direction it dictates, or you're writing the equation as the opposite. Okay? So to write that, and I'm going to write it because you don't want to leave those double signs right here. So that's y equals 1/4 times x minus 2 plus 3. So this tells me the opposite, right? So that tells me I'm going right 2, up 3. So that's true of the parent function for y equal 1/4 x. So it says, what did the y coordinate of the point on the translated line do when the x coordinate is 2? So of course, it went up 3. Block that function. All right, so number 10. Plot the point -1, 3 and graph the line through the point with a slope of 2. So let's do that. -1, 3. So left 1, up 3. Okay. And we're going to do through the point with a slope of 2. So that means 2, right? M equals 2. So if I'm doing a slope, that's rise over run. So I'm going to rise 2, run 1 from that point. Okay. Here's our line. Oops. Let's do a little bit better than that. So it says, explain how the line transforms y equal 2x. Well, we know 2x went through 0, 0, right? So what did we do from 0, 0 to get to this point? From 0, 0, you went left 1 and up 3. So it says the point 0, 0 on y equal 2x is translated to what point on the line y equals x. So here it is, y equals x minus -1 plus 3. So we went to point -1, 3, right? And if you think about it, if I wanted to rewrite this, because we don't like those double signs, what happens when you subtract a negative? Y equals 2 times x plus 1 plus 3. So even though we went left 1, and I want you to look right here, we went left 1, and it says plus 1. So that's why you do the opposite of what you think you should do when writing the equation for that x value. So if it says -1, that means you're going left 1, and that's going to have the opposite sign because of this right here. Because of that x minus h, right, up here at the top. All right, so it says, number 11, write an equation in the form of y equals m times x minus h plus k for the line that translates the line y equal 4x. So let's look at this. So if we're going 2 units to the right and up 1 unit, so that would be right 2, up 1. Well, remember, this is always going to be opposite. Oops. So here, when we write our equation, y equals, so it says 4x, so that's m is 4, times x minus positive 2, so that's the opposite, that means opposite of positive 2 is negative 2 plus k. And k, whoops, means we went up 1 unit. All right, so I want you to try B part. You may want to pause the video and try that one on your own. Okay, let's see how you did. So 2 units to the left, so it's left 2, down 1. So I'm thinking about the ordered pair from the origin when I write this. Left means negative, right? Left 2, down is the negative direction, correct? So left 2, down 1. So when we're writing the equation, using the same slope, 4 times x. Now remember, I'm the opposite of negative 2 is positive 2, down 1. So k always does what you tell it to, or what it tells you to. H, you always do the opposite. So that's something, an extra note you might want to write, and this applies to all the functions. And that's kind of the cool thing for this point slope form. And this is probably a different point slope form than you've ever seen. And that's okay. I like this one way better. And it works just the same. So your slope, so H, you always do the opposite. And it's because of this negative sign right here. Remember, to be negative just means to do the opposite. So you're going in the opposite direction here. So the opposite, we always say H is a liar. So if it tells you to go left, you go right. So do the opposite. And K, do the same. So if it's positive, you go up. If it's negative, you go down. H, if it's positive, you go left. Do the opposite of what it tells you. If it's negative, you go, whoops, right. All right, so that's something a little handy to think about. All right, so using translations, write the equation of the line in the form of m times x minus h plus k that has a slope of 4. And so it's telling you it has a slope of 4. So what does that tell you? That tells you m. All right, so I'm going to let you do number 12, and that'll be part of your submission for your work. So number 12, all right, and then 13, 14, 15, and 16 are just a little bit of discussion and practice. So it talks about what about that original equation, and then you'll answer the questions the best that you can, and then submit through a file upload. Just always be sure that your work is legible when submitting a file upload. All right, until next time. Yeah, just be sure that your file is legible. Your writing is legible before you upload it.